this video we're going to take a look at a couple of examples on how to graph quadratic equations so that we can build this form of the quadratic equation. F of x is a times the quantity x minus h squared plus k, where a, h, and k are very specific values. A we're going to call a scalar, and our scalar is going to tell us precisely how the parabola opens. H is going to be called our horizontal shifter, and by the horizontal shifter we mean how exactly the vertex of the parabola is going to be shifted horizontally, while K will be our vertical shifter. Now, if you don't know exactly what all of these mean right now, then just pay attention for the next few minutes, because we're going to construct how all of it works. Let's start, first of all, with the easiest parabola, where f of x equals x squared. So we have our x-axis and we have our y-axis. Often I like to say that the word f of x, the phrase f of x, is just a fancy way of saying x and y. Well, if we make an x and y chart, let's start with -2, -1, 0, 1, and 2 for values of x. So if -2, if x is -2 and I square -2, then -2 squared is going to be 4. So at -2 I will go up to 4, and I'll put a point there. Let's do that in the darker blue so we can see it better on the white. Alright, now if x were -1, -1 times -1 is 1. So once again I will go over to -1, and then I will go up 1, and I'll make another point there. 0 is easy because 0 times 0 is just 0. So I'll have another point at the origin 0, 0. And then interestingly enough, from that origin I'm going to go 1 times 1 is 1, and 2 times 2 is 4. So I'm going to curve right back up in exactly the same way as I did before, and really what I've got is a mirror. So here is our parabola, and up there. Good. So let's talk about a couple of things. First of all, this line here, the line that passes right through the vertex, is called the line of symmetry. Line of symmetry. And the line of symmetry is the line that passes right through the vertex. In this case, notice that it is a vertical line, which means it is x equals something. And in this case, x is 0 because it's not going left or right in any direction. So the line of symmetry is that x equals 0. Notice also that we have a minimum value. And in this case, again, our minimum value is the smallest y value right there at the vertex, because it opens up, I have a minimum value. And our minimum value is where y is 0. And we'll pay attention to lines of symmetry and minimum or maximum values as we construct our graphing form of the quadratic equation. But for now, just know that it is this line here is our minimum value. Okay, let's try a new f of, we'll call this one actually g of x. Let's try a g of x where g of x is 2 times x squared, so it's twice x squared. What do you think that's going to do to our graph? Well, for those same values of x and y, actually let's just do, let's go ahead and do -2, -1, 0, 1, and 2, because we know that once we reach our minimum value, it's going to mirror up. So now what we're being asked to do is to say, take x and square it, and then multiply that by 2. So if x were -2, we know that -2 squared is 4, but when I multiply that, it will be 8. So now I have the point not negative 2, 4, I have the point negative 2, 8, right? And because I have negative 2, 8, I'm also going to have 2, 8. Now let's try 1. 1 squared is 1 times 2 here is 2. So I have this value here at negative 1 and 2. And I also have this value here at, no, positive 1 and 2. Positive 1 and 2. And so if I were to graph, and of course I have the same vertex, so if I were to graph this one, notice that my graph is significantly skinnier, right? That's because I'm going up much faster than I did in the previous one, because I'm multiplying by 2 after I square. I have to scale it by 2. I have to scale it by 2. Let's try one more. Let's try where, let's see, let's use a different color. Let's go to orange. Where f of x is 1/2 of x squared. And this time we'll just use, for x and y, negative 2, 0, and 2. Same thing, we have to square our negative 2. Negative 2 squared is 4. Divide that by 2, and I've got 2. So at negative 2, I am only, see, 1, 2, and then we'll go up 2, go there, 1, 2, go up 2, we'll go there. 0 is 0, and this again is 2. Now what's going to happen here is I'm going to open up much wider. So you see how what's happening is that with our scalars, it's changing how the parabola is opening. A normal parabola, a parabola with a scalar of greater than 1, and then this parabola has a scalar of less than 1. Critical thinking question, what do you think would happen if I had an h of x where the scalar were a negative 2 x squared?